Okay, so now let's look at this example here and see what we come up with as far as like critical values using the equation from the theorem and find some critical values. Okay, so this is what we have. So here's our parametric equations and the range of t. So now let's start with taking the derivative of each one. X prime of t equals what? In this case, 2. Y prime of t is going to equal 3t squared minus 3. Okay, so now what are we going to do? We're going to take x prime of t over, y prime of t over x prime of t, and so we get 3t squared minus 3 over 2. Okay? So all I'm doing is using the equation from the theorem. So now, this will give me the slope, right? So again, this is the same as dy dx. Okay? So this is going to be giving me the slope at every point with respect to t along the parametric curve. Okay? So now, where are the critical values? Remember, the critical values are wherever this is equal to 0 or equal or undefined. Since the denominator is a constant, we don't have to worry about where it's undefined because it's defined everywhere. But we do have to see where the numerator is equal to 0, because if the numerator is equal to 0, the whole thing is equal to 0. So when is this going to be equal to 0? When t is plus or minus 1, right? So this is equal to 0 when t is equal to plus or minus 1, right? Why? Well, just look at it. Solve it, right? When t is 1, this gives you 3 minus 3. When t is negative 1, you get 3 minus 3. Okay? So when t is equal to 1 plus or minus 1, we're going to get 0, which means there's a critical value, right, at plus or minus 1. So now what we're going to do is we are going to plug in plus and minus 1 into these values. So let's do plus 1. Let's do 1 first. So t equal to 1. What do we get for x? What is x going to equal? Well, if t is equal to 1, we get 3. X is equal to 3. And y is equal to what? We get 1 minus 3 plus 4. Right? So we get 1 plus 1, which is 2. Right? Yeah. So that means when t is equal to 1, we have a critical value at 3, 2. Okay? Now, what about when t is equal to negative 1? Well, when t is equal to negative 1, we get what? We get negative 1 for x. And we get y is equal to what? Well, this is going to be negative 1 plus 3 plus 4, which is going to give us 6. And so this gives us the point negative 1, 6. So let's plot these. So 3, 2 is right here. And negative 1, 6 is right there. Okay, so let's plug in the value. So negative 2, what happens when we're in negative 2? Well, negative 2, we're going to add negative 4 plus 1, so that's going to be negative 3. And when this is negative 2, this is going to be negative 8 plus 6. Right? So that's going to give a negative 2, so that's going to give us 2. 3, 2. Negative 3 comma 2 is right about there. Okay, so at negative, so negative 2, so at negative 1, we already did, right? So negative 1, it's here. What about at t equals 0? Well, then we get 1, 4. So 1 comma 4. So 1 comma 4 is about right there. Okay? And then at 1, we already did. 2. When t is 2, what do we get? We get 5, comma 8 minus 6, which is 2, we get 6. So we get 5, comma 6. So 5, comma 6. It's about right there. Okay, and then at 3, I think we're, hold on a second. Right, so then it just keeps going up. So, what do we got here? So, what do we have is something that looks like this. Now, what do we have? Oops, hold on. Like that. Okay. So, well, at 3 comma 2, right, that corresponds to what? A relative or local maximum, and at 3 comma 2 corresponds to a relative minimum. So an extreme value, right, where the slope is 0. Right? Horizontal lines. The tangent lines are horizontal. Okay? So there you go. So we're able to find extrema. Okay, let's do the next one.